Here we are. Let's do some math, folks. All right, we're in section 4.5 now, as you see, and we are going to continue what we've been working on in terms of proving that triangles are congruent. And we're going to learn a couple new methods for that. As you can see, something called ASA and AAS. And simply the goal then is that you will be able to prove that pairs of triangles are congruent using the angle-side-angle congruence postulate and the angle-angle-side congruence theorem. Just two new methods for you to learn. And what I'd like to do is go through really quickly what the angle-side-angle congruence postulate is and what the angle-angle-side congruence theorem is. I've got them side by side here. They're both pretty similar. You're now familiar enough with SSS and SAS to kind of understand what the A's and the S's stand for. You know, every A stands for angle, every S stands for sides. And so since both ASA and AAS have two angles and two A's and one S in their name, you know that what we're going to do is we're going to prove that two angles from this triangle are congruent to two angles from this triangle, and that one pair of sides from this triangle is congruent to one pair of sides from this triangle. All right, that's going to be true for each of these two different triangle congruence methods. The difference is going to be where is the pair of congruent sides in each triangle relative to the pairs of congruent angles. All right, that's the difference between ASA and AAS. So let's focus in on the angle-side-angle congruence postulate. All right, now I'm going to state this out loud and then I'll fill in the blanks for what you see right here. The angle-side-angle congruence postulate would state that if you have a pair of triangles that have two pairs of congruent angles and the included sides of those congruent pairs of angles are also congruent, that makes the triangles congruent as well. Two pairs of angles and an included side. Two pairs of angles and an included side. I want to get that into your head. That's ASA. Now, what does that mean, two pairs of angles and an included side? So, let's just do some hypotheticals here. I'm going to pick two pairs of angles and say that they're congruent. And I'll do that in both sets of pictures here. So, angle A is congruent. Whoops, I didn't mean to put angle A is congruent to angle B. Let's say angle A is congruent to angle D, and angle B is congruent to angle E. There's two pairs of congruent angles. All right, now think about this for a moment. Two pairs of angles and an included side. There are three sides for each of these triangles. Looking at triangle ABC, which of these three sides do you think would be the included side for the angles A and B? Well, the included side of two angles is simply the side of the triangle that connects those two angles. And the side of the triangle that connects angle A with angle B is this segment AB. So that's the included side. And the included side then of angles E and D would be segment DE right there. So here I've got two pairs of angles and the included side of one triangle congruent to two pairs of angles in the included side of a second triangle. That makes the triangles congruent by angle side angle. Now I'm just going to write which pairs of sides were congruent and which pairs of angles were congruent in these blanks right here real quick. All right, so if angle A is congruent to angle D, angle B is congruent to angle E, and their included sides A, B, and DE are congruent to one another, then the triangles are congruent by angle side angle. Now, I want you to notice with angle side angle that the S is between the two A's. That's your clue that you're looking for included sides when you use angle side angle. Whereas, let's come over to the other postulate. With the angle side congruence theorem, we're still looking for two pairs of angles and one pair of sides that are congruent, but notice that in the name, the S is not between the two A's. Well, what we're looking at here is that if two pairs of angles in a non-included side of one triangle are congruent to the two pairs of angles in a not-included side of another triangle, that's another way of proving that the triangles are congruent to one another. So let me give you an example of what two pairs of angles in a non-included side would be. Let's suppose the exact same angles from before are congruent. Let's say that angle A is congruent to angle D, and that angle B is congruent to angle E. Well, we said that the included sides for those respective angle pairs are segments AB and segment DE because those are the sides that connect those angles. There are two pairs of sides that do not connect those two angles, and those two pairs of sides are the non-included sides for this angle pair. So, for instance, let's suppose we knew that segment AC was congruent to segment FD. Then you know that two pairs of angles and a non-included side of one triangle are congruent to the corresponding pairs of angles and non-included side of a second triangle. That's how you know the two triangles are congruent by angle, angle, side. Alright, so again, if angle A is congruent to angle D, angle B is congruent to angle E, and segment AC is congruent to segment DF, that would make those two triangles congruent by the angle, angle, side congruence theorem. Whoa, I realized I made a mistake over here on the left. The angle, side, angle is not a theorem, it's a postulate. And actually, along that thought process, every congruence method we've learned so far, other than HL, has been a postulate. And now we're learning a second congruence theorem. And I want to remind you that a theorem is something that you can prove, whereas a postulate is accepted as true without proof. And just to kind of reinforce that idea, I'm going to take a quick moment and prove that the angle, angle, side congruence theorem proves that two triangles are congruent to one another. So let's do that. You can copy this information down for me, please, and when you've done so, unpause the video and let's go through this thing. Now, always with congruent triangle proofs, it's the best idea for you to go ahead and start indicating the information that was given to you on your diagram. Any conclusions that you can make from this information need to be put on the diagram somewhere. So that way you can decide, do I want to use SSS or SAS or whatever to prove that the two triangles are congruent to one another. And so we know that two pairs of angles are congruent. We can go ahead and mark down that angle P is congruent to angle W, and that angle angle R actually, is congruent to angle Y. And then we're told that segment PQ is congruent to segment WX. Now, remember, I'm trying to prove that the angle, angle, side congruence theorem works, so I had to assume that there were two pairs of angles and a non-included side of one triangle that were congruent to two pairs of angles and a non-included side of a second triangle. Now, after this proof, every time we say that information, we'll go ahead and say the triangles are congruent by angle, angle, side, but now we're trying to prove that that works. Well, let's go ahead and at least list some of this information in our proof. Where I'd like to go with this is I'd like to start with stating that the two pairs of angles are congruent in statement 1. So there you go. And right now I'm going to talk about a little bit of the strategy that we're going to use. The way we're going to prove that the angle, angle, side congruence theorem is valid is by using the angle, side, angle congruence postulate. We're going to use one thing that we just learned to prove another thing that we learned works. And if we're going to use the angle, side, angle congruence postulate, what we would need to be able to do is prove that the two angles P and Q that include the congruent side PQ would be congruent to one another. So I need some way of being able to show that angle Q is congruent to angle X so that I can have an angle, side, angle scenario. And that's pretty easy. You might remember earlier in the chapter, we learned that if two angles from one triangle are congruent to two angles from another triangle, that the third pair of angles from those triangles have to be congruent. So at this point, we know for certain that angle Q is congruent to angle X. That's the next thing in my proof. And again, that's called the third angles theorem. That would justify that conclusion. All right. Well, I told you that the goal was to use angle, side, angle. Hold on a sec. I'm going to highlight some things. We've now been able to conclude that angle Q is congruent to angle X, so we know that all the angles from one of the triangles are congruent to all the angles from other triangles, but what's going to be relevant to us are these. All right, we're going to use the two angles and the included side here and prove that they are congruent to the two angles and an included side over there. And we've already done most of that work. We've already proven already written out in our proof that angle P is congruent to angle W and the angle Q is congruent to angle X. Now all we have to do is state that segment PQ is congruent to segment WX, the included sides, and that was given to us, so that'll be easy enough. And so then we know that triangle PQR is congruent to triangle WXY. by the angle side angle congruence postulate. Alright, so again, the reason AAS is the theorem is because you could prove it, and you can prove it using ASA. Now let's get on to some problems that just involve using these theorems and not proving the theorems themselves. Actually, one thing to do before then. There are now 5 methods that you've learned that you can use to prove that triangles are congruent. Well, 6 in a way. And I want to write those out, and then I also want to talk about methods that you might assume would work but don't actually prove that triangles are congruent. To this point, you've learned, and I'll start with the one that I wasn't going to include, but I'll go ahead and include it. You've learned how to use the definition of congruent figures to prove that 2 triangles are congruent. In other words, you can prove that every pair of corresponding sides and angles between 2 figures are congruent, and that makes the figures congruent. But then you've also now learned things specific for triangles, that you can use the SSS congruence postulate, that you can use the SAS congruence postulate. And while we're listing postulates, you now know that there's an angle side angle congruence postulate. And then there are a couple of theorems as well. Of course, we first learned the HL congruence theorem. Which works for right triangles only. And then we just learned the angle side congruence theorem as well. Now you're going to notice almost every combination of A's and S's that you can come up with is a way to prove that 2 triangles are congruent to one another. Hopefully there are a couple that you notice are missing here though. One of those is angle, angle, angle. And it turns out that angle, angle, angle is not a way to prove that 2 triangles are congruent. Now I'd like you to think about that actually. Why would it not prove that 2 triangles are congruent if you could prove that all the pairs of angles between the 2 triangles are congruent? I bet you could think of 2 triangles that have congruent angle measures to one another but are different sizes. Alright, and the other one that's not going to work is when you have 2 pairs of sides and a non-included angle. That does not prove that triangles are congruent to one another. Okay, well, let's use the 2 that we just learned. I want you to copy down this information here, and let's go through and prove that these 2 triangles, LPQ and TSQ, are congruent. Pause, copy the information down, and then let's do this. Now this is just coincidental that this is this way, but this is the first proof we've done together where we literally didn't have to mention anywhere in the given information that there were congruent segments or congruent angles. We are using different types of information that will help us make that conclusion, but it wasn't explicitly stated. So our job is to figure out then which angles or sides must be congruent based on the fact that we've got parallel lines and based on the fact that we've got one point that's a midpoint of a segment. Let's start with the parallel line. Segment LP is parallel to segment ST. Well, what does that mean for us? You'll remember, of course, that anytime 2 lines cut by a transversal are parallel to one another, that the alternate interior angles formed are congruent. And we have actually 2 pairs of alternate interior angles that are congruent to one another. Angle P would have to be congruent to angle S because of those parallel lines. And angle L would have to be congruent to angle T, wouldn't they? Now I need to make a quick note here. The fact that segment LP is parallel to segment ST does not by any means mean that those segments are congruent. For instance, aren't these 2 lines that I just drew parallel to one another? Are they the same length? Not at all. Alright, so we can't say that segment PL is congruent to segment TS, but they are parallel and they form the alternate interior angles that were congruent to one another. You do need at least one pair of congruent segments to use either ASA or AAS. And we're going to find a pair of those using this fact that Q is a midpoint of segment LT. Since Q is the midpoint of this segment here, that means it divides it so that segment LQ is congruent to segment TQ. Now we need to come up with a strategy for which postulate or theorem we're going to use to prove these 2 triangles are congruent. Notice that I've shown that 2 pairs of angles and a non-included side for one triangle are congruent to the 2 pairs of angles and non-included side of a second triangle. So we're going to try to use AAS here. Now some of you might be thinking, aren't the vertical angles congruent as well? Yes, they are. And if you chose to use the vertical angles along with angle L and angle T, for instance, you could possibly use angle side angle. Almost all the time that you use angle side, you could have used angle side angle instead. But I want to use just what I've marked on the picture right here. So let's state why each of these things are congruent to one another. Starting with the parallel line, so we can state why the angle pairs are congruent. And remember, because of those parallel lines that we were given, it made both the pairs of alternate interior angles in the picture congruent to one another, for which our justification will be the alternate interior angles theorem. And that, if you keep the little checklist that I've mentioned before, that's two pairs of angles from our angle side. Now we got to state why there's a pair of congruent sides, and the pair of congruent sides that we mentioned are only congruent because of the midpoint. So we got to state that Q is the midpoint. Then we can state that these two pairs of sides are congruent. That's next. So there's the Q as the midpoint. Now we'll say segment LQ is congruent to segment TQ. Now, one thing I forgot to mention in the previous proof, or remind you of, is that you do want to think about the fact that this triangle is a rotation of this triangle, right? I'd have to rotate around this point Q in order to map this one onto that one. So that's why I wrote these in the order I did. Point L corresponds with point T. Point Q ends up corresponding with itself. All right, and then that's the S from the AAS. Now, just because you write AA and S doesn't mean that you know it's angle side angle versus angle side. You have to look back at the picture for that. And we had two pairs of angles on non-included side that were congruent. So now we're going to state that the two triangles are congruent using the angle side congruence theorem. And of course, I realized I forgot to put a reason for statement number 4. The reason we knew that the two segments there were congruent is by definition of a midpoint. All right, now at this point the video is getting a little bit longer. I do have one more proof I'd like to do with you, but if you think you've got the idea, you could feel free to cut it off here. I would certainly recommend looking at the next proof. The biggest thing I need to teach you now is not an angle side or anything like that, but just how do you process the information that's given to you in order to determine what congruence method that you're going to use. So that's why I'd recommend watching this next one. But if you're done here, thanks for watching. And if you're not done there, start copying this stuff down for me. And then unpause and let's do this. Actually, you can do the proof on your own if you really know what you're doing. And then unpause. Otherwise, unpause and watch me do it. Just as with the last proof here, you notice that the given information doesn't tell you that any pairs of sides or angles are congruent. So we're going to have to dig in a little bit to see where those pairs of congruent angles and sides are. Now what it does tells me is that segment GB is perpendicular to segment CP, which we know that perpendicular lines form a right angle. In fact, they form 4 right angles at the lines. If I were to extend the line, I'd have more right angles here, wouldn't I? But we just have to worry about the 2 that are inside the triangle there. All right? And then the other thing that we're told is that segment GB bisects angle CGP. So this segment bisects this angle right there. Now I'm going to highlight that angle just so we know what we're talking about. This is the angle that's bisected. And if an angle is bisected, that means it's cut into 2 congruent angles. So angle CGB there would be congruent to angle PGB right there. Now, aren't all right angles congruent to one another? So there's one pair of congruent angles, and there's another pair of congruent angles. And then we've got one pair of congruent sides because we can use the reflexive property to say that segment GB is congruent to segment GB. Now, one thing I want you to notice here. These are right triangles, aren't they? But we're not going to use HL. You don't have to use HL every time with right triangles. It just happens to be the only type that HL works with. In this case, we can't use HL whatsoever. But we do know now that 2 angles and the included side of one triangle are congruent to 2 angles and the included side of a second triangle. So we're going to end up using ASA to prove that these 2 triangles are congruent. All right, if you've just wanted to stick around for the plan and then try the proof on your own, great. Go ahead and pause and then come back. I'm going to keep on going. Let's go ahead and start with the fact that we had perpendicular lines, which is given to us. And here's the thought process I need to follow with the perpendicular lines. The reason they were important is because it made 2 pairs of right angles, and right angles have to be congruent to one another. And so we're eventually going to be able to say that angle CBG is congruent to angle PBG, but it's going to take 2 steps to do that. What we need to do right now is say that because of the perpendicular lines, we have two right angles. So watch this. We're stating that those two angles CBG and PBG are right angles to one another. And how do we know that? Because of the perpendicular lines there. So we'll just say let's do the definition of perpendicular lines. Technically that's combined with another theorem, but let's just go definition of perpendicular lines. That'll be good enough for me. And remember, our goal is to prove that two pairs of angles and a pair of sides are congruent, so we need to be able to prove that these two angles are congruent. And now that we've stated they're both right angles, we're ready to do that in the next step. And get used to using this with right triangles and congruent triangle proofs. If no two angles are congruent because they're right angles, the justification for that is simply that right angles are congruent. Or if you remember the name of that, you could say the right angles congruence theorem. That works for me right there, though. Okay, so that's one pair of angles from our checklist. Now I'm just going to skip down to the next given information and use that, which was the fact that segment GB bisects angle CGP. And what did that help us determine? Well, that helped us determine that these pairs of angles were congruent. Angle CGB and angle PGB. So let's state they're congruent. And how do you know that two congruent angles are formed whenever a bisector bisects an angle? Well, that's the definition of an angle bisector. That's what those things do. And so now on our checklist, we've shown that two pairs of angles between the triangles are congruent. We still got to prove that there's a pair of sides, and it has had to happen to be the included sides if we're going to use ASA, that are congruent to one another. And that's going to use the reflexive property, right? Now you say segment GB is congruent to segment GB. Now a quick note, this top triangle is a reflection of the bottom triangle, so when you fold it over, G corresponds with itself and B corresponds with itself. We didn't need to switch the order of the name when we used the reflexive property just now. There's the second pair of sides that are congruent to one another. Again, don't worry, this says AAS there. It's what's in the picture that matters. That side is the included side of the two angles. So now we're ready to say that the triangles are congruent, and we're doing that based on the angle side angle congruence postulate. And voila, c'est magnifique. The proof is done. Alright guys, thanks for watching. I know if you made it this far, that took a lot of effort on your part. You should be okay at this point with proving that triangles are congruent. See ya later.